Namaste to everyone. I welcome you all in my YouTube video channel. Today, I will deliver lecture on degree level trigonometry, De Moivre's theorem, lecture number 4, in which I will solve some problems of complex numbers through De Moivre's theorem. Now, question is, with the help of De Moivre's theorem, solve the following problems. Here we have 4 problems involving complex numbers. Now, we will have to solve these problems with the help of De Moivre's theorem. Firstly, solve number 1. Let x equal to 3 by 2 and y equal to minus square root 3 by 2. Now we transform these variables in polar form. Since in polar form x equal to r cos theta and y equal to r sin theta implies that x square plus y square equal to r square cos square theta plus r square sin square theta equal to r square cos square theta plus sin square theta implies that x square plus y square equal to r square multiply 1 cos square theta plus sin square theta equal to 1 implies that r square equal to x square plus y square implies that r equal to square root x square plus y square, means here x is 3 by 2 whole square plus minus square root 3 by 2 whole square root, and this is 9 by 4 plus 3 by 4 square root implies that r equal to square root 12 by 4. This is square root 3. This is number 1. Now, r sin theta by r cos theta equal to y by x implies that tan theta equal to y is minus square root 3 by 2 and x is 3 by 2. This is equal to minus 1 by square root 3. This is number 2. Since x coordinate is positive and y coordinate is negative, here negative, here x, here y axis, x axis, y axis, negative of x axis, negative of y axis. So here x coordinate is positive, this is, and y coordinate is negative, this is. So theta lies in 4th quadrant. Therefore, theta equal to minus pi by 6. This is minus pi by 6, this angle, theta. Therefore, 3 by 2 minus square root 3 by 2 I to the power 10 equal to x is r cos theta. This is y is r sin theta, and here we have I r sin theta to the power 10. R is taken as common and then we take it outside, means r to the power 10 cos theta plus I sin theta to the power 10, and this equal to r to the power 10. This is cos 10 theta plus I sin 10 theta by using de Moivre's theorem. This is number 3. This is equal to r is square root 3 to the power 10 and cos, here 10 multiply theta is minus pi by 6, plus I sin 10 multiply minus pi by 6. This is equal to square root 3 to the power 10 is 243 cos minus 5 pi by 3 plus I sin minus 5 pi by 3. This equal to 243. If we add here plus 2 pi minus 5 pi by 3 plus 2 pi, there will be no harm, because we know that cos 2k pi plus theta equal to cos theta. Similarly, sin 2k pi plus theta equal to sin theta. Here k equal to 1. We have used k equal to 1 plus I sin minus 5 pi by 3 plus 2 pi. This is 243. This is 6 pi, means cos pi by 3 plus I sin pi by 3. This equal to 243. Cos pi by 3 means half plus I sin pi by 3 is square root 3 by 2. This is equal to 243 by 2, 1 plus square root 3 I. This is the required solution. Now we solve problem number 2. Here we have two parts. Firstly, we solve the first part. First part. 1 minus I to the power 12. Let x equal to 1, y equal to minus 1. Implies that r equal to square root x square plus y square, means 1 square plus minus 1 square. Here 1 plus 1 square root 2. Tan theta equal to y by x minus 1 by 1 minus 1. This is number 1, this is number 2. Since here x is positive, this is x axis, this is y axis, this is negative of x axis, this is negative of y axis. Here x is positive and y is negative, so theta lies in fourth quadrant. Since x is positive and y is negative, therefore theta lies in fourth quadrant. Therefore theta equal to minus pi by 4. Now 1 minus I to the power 12 equal to, here r cos theta, x is r cos theta plus I r sin theta, y is r sin theta. Let x equal to r cos theta, y equal to r sin theta to the power 12. This means this is r to the power 12 cos theta plus I sin theta to the power 12. Firstly write r to the power 12 by using de Moivre's theorem. Cos 12 theta plus I sin 12 theta using de Moivre's theorem. Here r is square root 2 to the power 12. Here cos 12 multiply minus pi by 4 plus I sin 12 multiply minus pi by 4 implies that 1 minus I to the power 12 equal to square root 2 to the power 12. This is 64. Cos minus 3 pi plus I sin minus 3 pi. This is equal to 64. We write here cos minus 3 pi plus, if we write here 2 multiply 2 pi plus I sine minus 3 pi plus 2 multiply 2 pi. The result will be same because we know cos 2k pi plus theta equal to cos theta. Similarly, sin 2k pi plus theta equal to sin theta. And this will be 64 cos pi plus I sin pi. This is 64 cos pi is minus 1, sin pi is 0. This is minus 64. Let this is number 3. Now second part. Equal to 1 plus I to the power 12. Here x equal to 1, y equal to 1. Let x equal to r cos phi, y equal to r sin phi. Here r equal to square root x square plus y square. This is 1 square plus 1 square equal to square root 2. This is number 4. Tan phi equal to y by x, 1 by 1 equal to 1. Let this is number 5. Since x and y both are positive, x and y both are positive. Here x and this is y. So x is positive and y is positive. So phi will lie. Therefore phi will lie in the first quadrant. Therefore phi equal to pi by 4. This is number 6. Now 1 plus I to the power 12 equal to r cos phi plus I r sin phi to the power 12. This is equal to r to the power 12 cos phi plus I sin phi to the power 12. This is equal to r means square root 2 to the power 12. Here by using de Moivre's theorem we get this is cos 12 phi plus I sin 12 phi. This is equal to 64. Here cos 12 phi means pi by 4 plus I sin 12 phi means pi by 4. This is equal to 64. Here cos 3 pi plus I sin 3 pi. We may write this as cos 2 pi plus pi, 3 pi, I sine 2 pi plus pi. This is equal to 64. Cos 2 pi plus pi is cos pi plus I sine pi. This is equal to 64. Cos pi is minus 1 plus I sine pi is 0. This is equal to minus 64. This is equal to number 7. Therefore, 1 minus I to the power 12 plus 1 plus I to the power 12 equal to minus 64 plus minus 64 equal to minus 128. This is the required result. Now we solve problem number 3. In 3 we have two factors. First factor is 1 plus square root 3i and second factor is minus 2 square root 3i. For 1 plus square root 3i, let x1 equal to 1, y1 equal to square root 3. Let x1 equal to r1 cos theta, y1 equal to r2 cos theta. Implies that r1 equal to square root x1 square plus y1 square. x1 is 1 square plus square root 3 square, means square root 4 equal to 2. Tan theta equal to y1 by x1. y1 is square root 3 by 1 square root 3. Let this is number 1. Since x1 is positive and y1 is positive, therefore theta lies in the first quadrant. Here this is x, this is y. Here x1 is positive 1 and y1 is positive square root 3. Therefore theta equal to square root 3, tan theta equal to square root 3 is pi by 3. Therefore 1 plus square root 3i equal to r1 cos theta plus I r1 sin theta equal to r1 cos theta plus I sin theta. Let this is number 2 and this is number 3. Now for minus 2 square root 3i, x2 equal to minus 2, y2 equal to minus 2 square root 3. Let x2 equal to r2 cos phi, y2 equal to r2 sin phi. Therefore, r2 equal to square root x2 square plus y2 square. Here minus 2 square plus minus 2 square root 3 square root. This is 4. Here 12. Implies that r2 equal to square root 16, that means 4. 10 phi equal to y2 by x2. y2 is minus 2 square root 3 and x2 is minus 2 square root 3. This is number 4. This is number 5. Since x2 is negative and y2 is also negative. Here this is x-axis, this is y-axis, this is negative of x-axis, this is negative of y-axis. Here x is negative, here negative, and y is negative. Therefore, phi lies in the third quadrant. Therefore, phi equal to up to this pi plus pi by 3. This is 4 pi by 3. This is number 6. Therefore, minus 2 square root 3 I equal to r2 cos phi plus I r2 sin phi. This is r2 cos phi plus I sin phi. This is number 7. Now 1 plus square root 3I multiply minus 2 square root 3I equal to r1 cos theta plus I sin theta multiply r2 cos phi plus I sin phi. This is equal to r1 r2 by De Moivre's theorem. If we multiply this, we get cos theta plus phi plus I sin theta plus phi. Here r1 is 2 multiply r2 is 4. Here cos theta is pi by 3 plus phi is 4 pi by 3 plus I sin pi by 3 plus 4 pi by 3 equal to 8 cos 5 pi by 3. plus I sine 5 pi by 3. This is 8. If we add with minus 2 pi, here cos 2k pi plus theta equal to cos theta. If we take here k equal to minus 1, then it will become minus 2 pi plus I sine 5 pi by 3 minus 2 pi. This equal to 8 cos here minus pi by 3 plus I sine minus pi by 3. This equal to 8 cos minus theta equal to cos theta, cos pi by 3. Here sine minus theta equal to minus sine theta. So here minus I sine pi by 3. This equal to 8 cos pi by 3 is half minus I sine pi by 3 root 3 by 2. This equal to, we take common half, 8 by 2, 1 minus root 3 I. This equal to 4, 1 minus square root 3 I, which is the required result. Now we solve number 4. Here, similar to 2, we may write one plus I to the power 8 equal to square root 2 cos pi by 4 plus square root 2 here I sine pi by 4 to the power 8. This is square root 2 power 8 cos pi by 4 plus I sine pi by 4 to the power 8. This equal to 16 cos 8 multiply pi by 4 by De Moivre's theorem plus I sine 8 multiply pi by 4 equal to 16 cos 2 pi plus I sine 2 pi. Let this is number 1. 1 minus I to the power 8 equal to square root 2 cos minus pi by 4 plus I square root 2 sine minus pi by 4 to the power 8. This is equal to square root 2 to the power 8 cos minus pi by 4 plus I sin minus pi by 4 to the power 8. This is equal to 16 cos minus pi by 4 multiply 8 plus I sin minus pi by 4 multiply 8 by using de Moivre's theorem. Implies that 1 minus I to the power 8 equal to 16 cos minus 2 pi plus I sin minus 2 pi. This is equal to 16 cos minus theta equal to cos theta, cos 2 pi here, sin minus theta equal to minus sin theta, minus I sin 2 pi. Let this is number 1, this is number, let this is number 2. Subtracting 2 from 1, we get 1 plus I to the power 8 minus 1 minus I to the power 8 equal to 16. We take common 16 cos 2 pi plus I sin 2 pi minus cos 2 pi minus I sin 2 pi. This equal to 16 cos 2 pi plus I sin 2 pi minus cos 2 pi plus I sin 2 pi. This equal to 16 multiply 2I sin 2 pi. This equal to 16 multiply 2I multiply sin 2 pi is 0 and this is 0. This is number 3. Now 1 plus I to the power 8 multiply 1 minus I to the power 8 equal to, this is 16 cos 2 pi plus I sin 2 pi multiply. This is 16 cos minus 2 pi plus I sin minus 2 pi. This equal to 256, and this multiplication means with the help of de Moivre's theorem we get cos 2 pi minus 2 pi plus I sin 2 pi minus 2 pi. This means 256. This is cos 0. plus I sin 0. This equal to 256 multiply cos 0 1 and sin 0 is 0. 1 plus I into 0 means 256. Therefore, this equal to, here result is 0 by 256 equal to 0. This is the required result. Thanks for watching my video. If you are satisfied with my presentation and contents, then please click on like button and do subscribe my YouTube channel. Thank you.